So we have approximately, let's wait, we have folks been joining. Okay, fine. We'll start. Okay. So good evening, everyone. So am I audible today, right? The voice is clear, correct?
Yes.
Can anyone just, it's better, right?
Yes.
Okay, great. So fine. So we'll just have a quick revision of the tour of whatever we had a discussion yesterday. Okay. So I'll just will have a quick look from the folks who are there. For example, Lata, can you unmute yourself and just let us know, revise what we had a discussion yesterday? For example, which is the file we discussed yesterday?
Yes, ma'am. Timing library .db.
.db or .db was the converted by the tool. What is the
Sorry,
format which has been provided?
.lib. Sorry, ma'am.
Huh?
.lib.
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 Correct.
Timing
Fine.
library.
Yeah. So timing library or a logical library is provided in the form of .lib. Correct. So it is provided by whom? Who shares this file with us?
Vendor.
Vendor. You don't call it just a vendor. See, vendor is a very term which is common to all, right? Even you have a vegetable seller vendor, right? You have to call it as a standard cell library vendor, right?
Okay, ma'am.
Correct. It can either be a standard cell library vendor or it can be provided through foundries as well, right? Correct, right?
Yes, ma'am. Yes.
Okay. So let me go. Ravichand, are you there today? I'm not sure why. Just can you just unmute yourself? At least say yes. You're there in the call. I don't want just the folks to join the meeting on the namesake, correct? Hemant, you are there? Hello? Hemant, you are there in the call?
Yeah,
I cannot.
yes, ma'am.
Okay, Hemant. So you were there in the yesterday's lecture, right?
No, ma'am. I'm new to the lecture as to.
Okay, fine. So let's go to Shiva. Are you there? Guys, just unmute yourself and say yes. Shiva. Venkat, you are there, correct? Yesterday also you are there,
Yes,
correct?
ma'am. I was there.
Okay. So Venkat, can you just let me know what are the contents of the library we went through, timing library or logical library yesterday?
Yes, ma'am. So first we have functionality of the cell. I mean
Okay.
reference name of the cell
Hmm.
and what are the units.
Okay, correct.
Maybe if it is a timing related, then nanoseconds or picoseconds. If it is a area related, maybe micrometer square or power related in terms of watts, microwatts or something.
Okay, units
And
are
all,
there. Hmm.
yeah, and also the pin information, whether
Okay.
it's direction, input or output in the timing library. I'm saying, and
Hmm.
also the area information
Correct. Hmm.
and also our power information. So yesterday we have seen regarding leakage power for each of the
Yes.
cell. What is the leakage power? We have seen some examples, and also how we are calculating the delay, cell delay using input
Hmm.
transition and output load. So the cell delay primarily comes in the timing library file, and also for the flip flop, if we have seen delay value. Timing arcs
Hmm.
we have seen. I mean, for combination cells we have seen positive unit, negative unit. For sequential cells we have seen some of the clock to D arc, clock to Q arc, and there are removal arcs, recovery checks. Removal checks, recovery checks,
Recovery
and
and
setup
removal
and
with
time.
respect to your
Yeah.
asynchronous pins. Great.
Yes, ma'am. Asynchronous
So,
sprints, and with respect to clock pin, we have, I mean, sit up and hold. And
okay.
other than that,
So this was the overall summary of this. Thank you so much. So those who are new to this lecture, so just go through the yesterday's recording. We just covered something related to timing library or logical library. Okay. So we had discussion about the timing library has a major content which is called as the cell definitions. Then it has its related pin information. If the pin is, let's say for an AND gate, we have input pins A and B, we have an output pin Y. So these all pin information are present. Then we have timing arcs. For sequential cell, we have timing arcs for flops, which state how does the D and clock pin of a flop relates through setup and timing or setup and hold. How does the clock to your CDN pin, which is called as asynchronous reset or clear pin, there is a recovery and a removal arc. Then from your clock pin to your Q pin, there is a propagation delay arc. Okay. And in your combination logic, we have seen that this arc are referred by timing sense as the unit and which is referred to the unnateness. Okay. Then there are capacitance value defined for each of this pin. Along with that, for flops, we have seen there are setup and hold time value. The setup and hold time value is not exactly a constant value. This also depends upon, it is also in form of lookup table, okay, which depends upon your input transitions and transitions and your clock transitions. Then we looked at each cell has a power related information depending upon the conditions of the input. Okay, if one is high, other is low, one is low, other is high, if both are high and both are low. So we see how this power information is present, how we have the delay values. Okay. And then the last one, we had even the PVT units. So now what we will be covering today is the next one, which is called as your physical library. Okay. So now if you look at this physical library, in the physical library, the extension I have mentioned is called as .lef. Okay. So anybody is aware that why it is called as .lef? What does .lef stands for?
Stands for, we know, layout exchange
Layout
format.
exchange format.
So it contains the metal layer information, what metal layers we are using, and
Okay.
also its width, spacing, pitch,
Just
and for,
I
yeah,
am not sure, but I think lef stands for library exchange format, right?
Yeah, yeah, yeah.
I, not
Library
sure.
or
library
liberty.
Normally, I have read it as library exchange format. I also refer it as library exchange format. I'll once again cross check if it's layout exchange format. Okay, so fine. Now this physical library. Now, one of the persons stated it has information related to metals. Okay, so this
And
physical
via
library.
information.
Hello.
And also, hello, ma'am. It contains via information in that file.
Yeah. So I'm just going to explain. See, the physical library is a bigger umbrella. Now it can be divided into two different libraries. One is your standard cell physical libraries. Okay. And second one is your technology library. Okay. So whatever information you are stating related to your metal layers, your VRs, these all comes into the category of, if you look, this comes in the category of .techlef file, .techlef or somebody .tf. Okay, so that is termed as techlef. So that is technology library. And one is which we are going to first see is called as standard cell physical library. Okay, both comes under a bigger bucket which is called as physical library. Fine. So now you understand that this .lef is an extension for your physical library, which stands out for library exchange format. I'll cross check. I've noted down whether it stands for layout exchange format. Okay. Then the second thing is we have to always understand like in which format it is written, right, guys? Because when you appear for the interview, they might ask you, right? This file is in which format? This file is in which format? For example, we have yesterday looked at timing library. It is .lib. Okay. Then somebody stated that the tool internally use something called as DB. So lib to DB conversion is done by the tool. Okay, because .db file is not a human readable format because it's in a binary format. SCI is the file which we can read it. So when the foundry or your standard cell vendor provided this file, it is also provided in the form of SCI. So the extension is .lef, format is SCI, and this file is provided to us same from the foundry or to the standard cell library vendor. Okay, so now we'll look into the content of this file. Okay, so now I have taken one example. Okay, if you look at this example, now you see the first keyword that is mentioned over there is macro and 2x2, correct? Now, when you looked at your timing logical library, your timing library file, right? In front of each of your this cell name, whatever is your either uh, combination cell or your sequential cell, you had a keyword called a cell. You remember? There was cell and then there was a cell reference name. Okay. So what happens? The left has its own format and it is being represented in the form of keyword macro. So what happens is, if you, for example, you want to grep, see, the timing lib and your physical lib should go in sync, right? Whatever cells is present in your timing lib, the same physical definition has to be present in your left as well, right? So for example, you are running synthesis, and while doing this, you face some issues. I'm not sure if you have run it, you will face some linking related issues, okay? And when the linking related issues comes, this is mainly related to the library. Maybe let us say see, this is also all the files which are generated by the standard cell team. It can happen when they are generating this team, due to some mistake, it happened that the cell was being defined in the left in the physical library, but somehow they missed to denote its logical related attributes in your timing library. Okay, so then it will give you a link related issues. Mainly that link, it has a word as link 005 error. Okay, so what happens is, if you want to check, for example, whether all the cells which are in my lib are also present in my left, so how you'll do? You'll grab the cell keyword in your library. You'll get, okay, it has 100 count. Now you will open up the library, a left physical library, and what you will grab here is a macro keyword. Okay, and then you have to get 100. So that is where the timing library and my physical library are having the same cell count. Okay, so macro is the keyword in front of all your cells which are being present in the design. Here they are not using the keyword as cell. Okay, now the second thing, if the macro, so you understood that the cell name here is a two input AND gate. Okay, now the next keyword which is present over here is called as class core. Okay, you guys are aware about like core and die, correct? A concept of core and die.
Yes, ma'am.
Okay, so for those who are not aware, right? For example, let me say I have this I have this area. Let's say this is the kind of a B box I'm referring to. This is the die on which I need to design my chip. Okay, so this complete die, let's say it is 14 square. Okay, I have given this bin area. Now this complete area is not under my use. What happens is, we have something, we have an internal shape within this, and this is the area available for me to design my chips. Okay, this periphery is for some different use. So what happens is, the outer boundary is your complete, let's say from here to here is your complete die area, and whatever is present for you to place your standard cell logic and everything is present only in your core area. Okay, in this whatever this is called as core to die spacing. Okay, I will write it as C2D as of now. This is called as core to die spacing. Every technology and everything has a specifications, like you have to follow some, that you need to maintain this much amount of space between core to die, and all these things calculations are being done at the higher level. We get this as an input, but you need to understand the terminology that your core to die space is being used. For example, if you will go in the later lectures, we'll study about something called as, when you're doing power planning, there are something power stripes, power rings. Okay, so power rings are placed in this core to die spacing region. For example, the ports are being placed around this region. Also your IO pads are being placed around. Okay, if you're not sure what is an IO pads, you would have heard about it. For example, see, IO pads are something which is kind of, they are in connection between your real logic which is present in your design to something which is present at the external world. They are a kind of a mediator. Okay. So to enable the chip communication, right, of the core logic with the external devices, we have this special kind of IO pads. Okay. If I have to give you, I'm not sure if I have to explain you very great detail about ESD circuitry or something. If let's say in your, let me correlate it to your real world example. Where do you have heard about the term MCB, guys? In your home, you have heard about MCB, that
Yes,
people are
ma'am.
guiding you that please install MCB in your houses.
Yes, ma'am.
Okay, so MCB is nothing but, if you, it's a kind of a circuit breaker. Okay, it stands for, I think, miniature circuit board or breaker. So it's a circuit breaker. Okay, what does it do? what happens is, for example, there will be a lot of appliances in your home. Let's say you have a AC, you have a fridge, you have washing machine, you have TV. Okay, due to some voltage spike, okay, there will be a lot of current that can come in your appliances, and this will damage your device, right? So in order to protect your device, you have the circuitry which is called as MCB. So once you're, if there is a power spike or current spike, right, you will say that today MCB has tripped. Tripped means it automatically is the switch is up, and when MCB gets tripped, it falls down. Okay. So same way, what happens is the signal. This is a something. See, whatever you are designing, let's say your complete, let's say it is your chip you're designing is a part of very big design, let's say SoC. Okay, this is your, for example, within this your SoC, somewhere the thing you have designed is over here, but the way the power is coming, maybe it is from here, so it has to travel and something has to come up over here. So these IO pads are being there to protect your protect your internal core logic. Your core logic should not get burnt out. Okay, so they have this concept of IO pads which are being installed. This is just for your guidance. I'm giving like what is that. So these IO pads are installed in this core to die boundary. They are not present something within the core area. Your power rings are also not present something within the core area. Your power stripes are something which can go ahead, right? When you draw the power stripes, right, you will draw it across your design. Okay, your VDD, your VSS stripes might go, but the power rings are something which are surrounded on the nearby core to die area. Okay. Now this class which I have mentioned, here I am presenting it's a value core. Why? Because it is telling you, or it is telling or guiding the tool that this macro, which is nothing but your standard cell, is only allowed to sit in your core area. Okay. Similarly, if there can had been a definition of an IO pad, it will say that you are allowed to sit in your pad. Okay. No, not pad, IO. Okay. So it will say you're allowed to sit in your core to die spacing. You cannot sit over here. So this is the way that this class has been defined. Now comes the next logic, next attribute, which is mentioned as origin. Okay, which is mentioned as 0, 0. For example, guys, how many of you have really worked upon any project using ICC2 or FC or Genus Tempest, Genus Universe, anything?
Yeah, ma'am,
Have
I
you,
work.
how many folks have worked upon?
Yeah, I'm not interested.
Only one folk have done this?
Yeah, I too have done.
Genus, ma'am.
See, Genus, fine. Any of your synthesis or PNR tool, only few folks have looked upon it, correct?
Yeah, yeah.
Somebody worked in ICC2 or FC?
Yeah, ma'am, I worked on ICC2 also.
Yeah.
ICC2.
Yeah.
Who's speaking? May I know?
Hemant.
Hemant. So Hemant, have you ever looked upon what does an origin of the cell try to state?
Yeah, in starting when we are before the placement, the all the cells are placed at the origin only.
Okay,
Even
and
the
after they are being placed, what does this indicate? I want to understand what this origin value means.
means left bottom corner.
Left bottom corner. Okay,
Yeah.
so what happens is, guys, this is, for example, this cell. For example, when let's say I try to erase this one. Okay, let me consider this itself as my design. Okay, this is the block A which I have been given to design, and this is related to some camera related logic. Okay, now for this is called as block. Okay, guys. For example, whatever, let's say block, partition, your whatever you're working, let's say this is the block A which I'm working. So this block has something which is called as origin. Okay, the origin is nothing but this coordinate. Okay, in industry standard, you will always refer this as LLX, LLY. Okay, what does it stands for? Okay, lower left X coordinate, lower left Y coordinate. Understood? So this complete design has an origin LLX, LLY. Okay. Whenever, for example, you're working on your design, whenever you try to get an attribute, for example, when we'll work with this tool, right? The command to get it is like you will try to get attribute. Inside that, you will write a command as get your designs. And then what attribute you want to look, it's called as origin. Okay, so it will give you 0, 0. For example, now there is a, let's say this is one cell. Okay, I'm referring the cell in this box. Okay, this is an, let's say this is an AND gate. Okay, so this cell will now not have a value as 0, 0. For example, let's say this was 0, 0. This was, let's say, 100 cross 100 design. Let me say this is the way I'm representing. This is the B box of my design. Okay, now this will have some value as 20 cross, let me say, 30. Okay, so what does it indicate? From this, from my design boundary, I am having an X distance of 20, and from this I am having a Y distance of 30. So always origin try to make a sense of LLX and LLY. It does not give you the B box or the boundary size. Okay, it just give you where is my lower left X corner and lower left Y corner. Now this is with all with your designs. But what happens is when the timing, this library characterization team is developing all the cell site, for them, the cell origin is always 0, 0. Why this is needed, I will let you know why when we go further. But all the cells in your design at in your left will have an origin 0, 0. Okay. Now let's come to something which is present next is something related to foreign and this something. Okay. Now what does this foreign try to states? Okay. See, if you look at in terms of foreign, it is trying to say the same cell and again 0, 0. If I have to explain with an example, let's say I stated you whenever we are getting a, let's say D flop, okay, and that is a scannable D flop. I'm saying SDF, guys. You know that whenever I'm referring SDF, it means a scannable D flop. Internally, we might know that it will have something called as mux followed by a flop. Okay, it will have scan input, data input, your scan enable. Then there will be something, this can be your clear logic, this can be your Q logic. Okay, then something for your clock. Okay, now this, when you refer that inside any design, if there are cells or this is termed as an hierarchical cell because there is inside this complete box, it's not a single cell. Okay, so what happens is it can happen that there are two cells. It will, this cell will have one location, this cell will have another location. Okay. At that time, it might happen. Nowadays, the foundry is not revealing. See, this can only happen when you are working with soft macros. Because I told you, right, there are two kind of macros which are soft and hard. The foundry which have developed these cells, they doesn't want to know what, we don't want to reveal you how we have designed these cells. Okay. But in case you have asked for some soft macros and you are developing it and then you are dumping this left. Okay, so your left will have something that inside this my cell, there is one foreign cell name as this and one is the foreign cell this and their B box and their origin. Okay, it will have foreign something mux, it will have this origin, then it will have a foreign flop and it will have this origin. But since this is not any hierarchical cell, this is a pure single standard cell, right? So it is trying to say there is only this cell and it is having an origin 0, 0. Okay, this is only useful when we are working on specifically soft macros and those have this kind of designs which have multiple cells in it. Then it will throw, okay, in this complete B box, I have two cells and that is their origin. Okay, now we are here. The next attribute which you look is something which is mentioned as size. Okay, now from this, if you have from this size attribute, what can you find out? If you just look at it, can anybody just tell me when you are looking at it, what it is trying to depict?
Length and width.
Length and width. Okay, so why was the same attribute available in my even timing library? Was this attribute even present in my timing library as well?
Maybe there we have only area, ma'am.
Yeah, there we have an attribute which is called as area, correct? There was no specification related to your length width, right? Correct. So here also, see, if you want to calculate the area, what will you do width into length, correct? Similarly, but instead of doing this complete, they gave the complete area information over there. But since this is a physical library, they wanted to give you the exact dimension of this box. Okay. So what, see, the cells which are coming, if you open up, you will always get in the form of boxes, okay? So what they are saying that this has a width of this much and my length of this much. Okay, so this is this physical dimension of the cell,
Ma'am, these are with length and width or width and height, ma'am.
wide and length.
Okay, ma'am.
It's width cross length.
Okay, ma'am.
Okay, so now you have looked upon the physical dimension. Okay, this is my width, this is my length, this is my origin. Okay, next attribute which you look into it is called something as symmetry. Okay, now if you will work in your this thing, right? For example, let me say if this was my, let's say I'm drawing, this is my B box, or this is my design. Okay, now what happens is I am drawing, let's say very simple example, an AND gate. Okay, A, B, and Y. Okay, I am allowed to keep the cell in this way also. Okay, am I allowed to keep a cell in this way? Can I place a cell in this way? Am I allowed to do this?
Yes, ma'am.
Okay. Okay, let's say now, for example, I am keeping the same cell over here as A, B, and Y. Am I allowed to keep a cell having B, A, and Y? Is there any issues? So now if you look at it, right, what has happened over here, this A, B, and Y. Okay, now if you mirror across Y axis, how will it turn into? It will turn into this one. The Y axis is nothing but your vertical line, right? When you mirror it across this will come into this way, right? So they are trying to state that whatever cells are there in the design, you are allowed to flip it across x-axis. You are even allowed to flip it across y-axis, right? For example, if this is my x-axis, right? Guys, this is a normal geometry. You're trying to understand it, right?
Ma'am.
So if at x-axis also you can flip it, correct? So this is the way that they are telling whatever cells are there in my design, you are allowed to flip across x-axis and y-axis. Sometimes there is a guidelines, not for standard cells. Standard cells are mostly there. Some few cells which are there for either sequential cells, or if there are some standard soft macros that are being designed by some of the organizations, they say or they have made it in such way that please don't flip it across y-axis. You're not allowed to flip it across y-axis, just flip it across x-axis. So they will give you only one symmetry. Okay. For example, in the later lectures, once we come to the floor plan stage, you would know that if you look at the cell orientation in your design, you will have something word as keyword as F. At bottom of every cell, there will be something called as, you look at it as F. If something, this is called as, if it can be in this way, it can be in this way. That will I'll explain to you once we go through this complete floor plan stages. This is called the orientations you are being allowed to even rotate it. MX, MY, RX, RY, 180, 270. Okay. So now they are stating that you are allowed to flip the cells across both the axis X and Y. Now, hello, guys,
Ma'am,
am I
if
audible?
yeah, ma'am, you're audible. Ma'am, if
Okay.
this is so, we can't. It's like the power supply will be flipped, no, right, ma'am? The VDD gets
Yeah. The power supply will be, see, in y-axis, if you're flipping, no change, correct? Above one was let's say above one was VDD, below one was VSS. Okay. Now when you're flipping it in y-axis, does it cause any change? VDD and VSS, will it change? No. The change will happen only when you're flipping around x-axis, correct?
yes, ma'am.
Okay. So what happens in the industry, right? If you go, let me erase it.
If
Let me
so,
draw.
then why it is allowed, ma'am, along y-axis?
Okay. Let me see. For example, I'll just answer your question in 1 minute. Okay. Let's just finish this attribute. Okay. Site as core site. Okay. So what happens is, right, guys, if you open up any of your designs, if you have ever worked with any of this PNR or FC PNR, like synthesis or PNR tools, either Genus or Innovus or through ICC2 or FC, see, every cell cannot sit anywhere. there is a particular way that you have to tell the tool where I can sit. Okay, it has even lot to do with the foundry. They will also give you that manufacturing grid is this much, but just for your easier explanation, what happens is, right? See, there will be something which if you open up, you will see orange. It's mostly in your orange. There will be a lot of oranges line, okay, in your design. Your complete design would be this lines, okay, and this line is nothing but this is called as your site row. If you look in your panel in FC, right, once we are opening up the tool, I'll show you there will be something called a site row. Okay, see, when you're driving your car, there will be different lanes, right? You can't drive the way you want. There, for example, there are 10 different lanes. Let's say 5 lanes are going in the upper direction, 5 lanes are going towards the west directions. So you when you're driving towards east direction, you cannot enter into the west lane, right? And when you're going out of this, don't try to just go out of lane one. Out of 5, when you're driving, drive in lane one. This is kind of a guideline we have, right? Similarly, the cell cannot be placed anywhere. The cell has to be placed in something which is called as core site. Okay. So what happens is they have segregated your complete design into small units. Okay. So these are called as site row. And there is also a vertical lines in your design. Okay. So what happens is, right, this is being defined even by your foundry itself. What they do is, okay, so this is the one cell site. Okay, so that this is called as one cell site. This is the basic logic. The smallest cell in the design can be allowed to fit over here. Okay, the way even see the team or TSMC team or the standard cell library vendor team, founder team, they are not allowed to make the design of their choice. Okay, that I can, okay, today I'm making 0.95 to 2.57. Let me go and increase it by 0.96. No, even all these things are decided by the technology rules which are set by the foundry, right? See, foundry does at the end, your complete chip is being designed by foundry. So foundry is making the thing, so it has its guidelines. See, my machine works with this much resolution. I need a manufacturing grid of this much. So they are telling these guidelines and they have to abide by it. Okay. So what the site is trying to say that you are allowed to sit within the site rows only. Okay. Now I'll come to that question where the person asked, like, if you're flipping it across your x-axis, what happens? See, if you're going through the power planning, right? Now, if you look at your power planning, if you will always have your first, let me say that the first power stripe you draw was VADD. Okay. The next power stripe will always, now modern technologies, everyone have a next stripe as VSS. Nothing but your, yesterday I stated, right? VSS is nothing but your ground. Okay. Then again, it's an alternate zigzag pattern. Okay. VDD, then your VSS, then it goes on VDD, VSS, VDD, VSS. Okay. So what happens is, for example, if your cell was sitting over here, okay, let me change the color. Okay, so cell was sitting over this, cell 1 was sitting over here. The cell had something as VDD and the cell had something as VSS. Okay, now the person who asked the question, can you just unmute yourself? Who was it? I'm not sure.
Sorry, yes, ma'am. I'm
Okay,
there.
now for example, if I'm flipping it across y-axis, okay, so y-axis is this one, correct?
Yes, ma'am.
So what will happen is when I'm flipping, this cell will not be sitting over here. Let me say like I'm placing the cell over here.
Okay.
Okay. Now earlier, yellow color is that thing. See, now let me say 1 and 2. So 1, it was sitting, okay, in this way. 2, it came in this way, correct? I
Yes, ma'am.
flipped around y-axis, but
Yeah.
your VDD pin and VSS pin, did it get changed?
No, no, ma'am.
No. Now I'm saying I want to flip it across x-axis.
Yeah.
Okay, now when you're flipping across x-axis, what happens is this will get inverted and come over here, correct? Let me say, in the same core site, you can't sit your cell, correct? You have the next core site which is being available.
Yes, ma'am.
Okay, because now
Okay.
this will have your VDD.
Okay, okay.
Okay, within the same cell site, you're not able to do, but there is a nearby cell site over which you can place it, correct?
Yeah, ma'am.
Okay, otherwise if you're swapping it and making it this, you will definitely see a power ground short, right?
Yes, ma'am.
that your VSS pin of your this is being attached to VDD.
Okay.
Okay, so now you
Okay, ma'am.
understood that you are
Yeah,
being
ma'am.
allowed to swap it, but then the core site or the cell site placement will have to change here and there.
Okay. I got it, ma'am.
Okay.
Yeah, ma'am.
Okay, fine. So now we understood, for example, what are the basic units which are present for your macros, and that what defines your physical dimensions of your cell. The main was your width and height. Then is what is it the class, whether I am a class core or in my IO, where will my cell sit? It will sit in my core sites. Okay. Now it will again have the information related to your pins. Okay. Now if you look at it, it shows one of the pin as pin A. Okay. Then it will again show you something which is direction input. Same information was even present in your timing library. Okay. But one additional information which is being present is something which is called a signal. Okay. See, we have something which is called a signal. Then there will be something which is called as power and ground. Okay. So now it is trying to tell the tool that this pin will always receive something which is called as a signal. It can be a data signal or a clock signal. Okay. So this pin is now a data signal. We understand, but tool understand its form of signal, or it can have another value as power or ground. Okay. Now there comes to something which is called as a port. See, for us, okay, you need to understand that when the standard seal have, see, what has happened is, for us, when we refer in our terminologies, we call this as a pin, right? Pin A,
Ma'am,
pin B, and
ma'am,
pin Y, correct? But in the physical, you have always seen what's the difference between pin and port, correct? You always say, okay, there is something this is called as logical. Logical is something which is called pin, and there's something which is called as physical, which is port. But you need to understand that there is a minute difference, but this terminology is very important. See, when they have designed it in the form of a pin, they have given you this kind of a B box, okay? They will provide you in the form of, this is the cell in the form of B box. But for us, this pin is equivalent to the port, which are we will see, right? See, port normally it's been defined in this way, okay? This is the way, for example, if somebody is simulating or something, we'll define this port as this way. In case of standard cell, as of now, because it's a single standard cell, there is no hierarchical designs in it, right? We call this as pin, which is equivalent to the port. So they are saying that pin or port is having some metal layer specifications, correct? Now they have stated that this pin, or now we are defining in terms of port. Now port will have a physical attribute. Okay, this is not something that you can just state it, okay, this is the pin. You have to state it is defined in which metal layer. Okay, so it is saying that we standard cell team have made this port A in metal layer metal 1. Okay. Now there is something which is called as rect. Okay. What does this define and how does it have a significance? Now, if you look at this, there are 4 coordinates. If you look at it, right? 0.1475, 0.84, 0.225, and 0.9825. Whenever a tool gives you a B box, okay, understand bounding box, or you call it as a boundary, it will have always 4 coordinates. Understand, first coordinate will be LLX, LLY. The next coordinate is referred as URX, URY. Okay, LL stands for lower left, X and Y coordinates. UR stands for upper right X, upper right Y. Okay, now you need to understand what it is trying to state. For us, we just understood it is a pin. Okay, but how is this pin being designed? Okay, it will have a metal layer attached to it. Okay, now it is stating, okay, this pin has something in a metal layer shape of metal 1, and the B box of this metal shape is defined over here. Okay, it is trying to say it, I am in a rectangular pattern, and this is my lower left X, lower left Y, and this is giving you upper right X and upper right Y. And how is this defined? This is defined with respect to your origin. Okay, so when you will see that this is your this, okay, your 0, 0. So it is saying that at least 0.1457 from the x-axis, and from here I am having one of this is where, okay. So 0.1475 from here and 0.8475 from here, I am the lower left x corners of your port A. and this is my URX, URY. Okay, so that's why there is a significance of this origin. As of now, all of your cells will have this origin as 00 until and unless you have specific IP or soft IPs which are being designed it and you have an internal cells within it, then your origin will alter. Otherwise, all the standard cells have an origin of 00. This is provided so the tool understands that from 00 origin, where is my port layer? Okay. Now, the next thing is,
Ma'am, 1 second, ma'am. I have a
Hmm?
doubt here. You here the site, at the site, ma'am, we have core site number here.
core site.
Yeah, do we have a chance of placing cells other than the core area, ma'am?
No. See, whatever is your standard cells which are being defined, I said IO pads, power rings, those are the one which are allowed to sit outside. Okay. But the one which are not, all your standard cells, see, this is a standard cell library, correct? All of your standard cells library are allowed only to sit within your cell site. Okay. There is a terminology which I stated, right? Cell site, correct? Which
Yeah,
I
ma'am.
said that one is your, if you look in your design, correct? I mentioned.
Yeah, we have site rows on that. We have seen.
Not only site rows. See, you will have everything with related to site rows. Even you will have vertical thing. Okay. When you
Okay.
turn on cell site, you will get this complete B box. Okay. You see,
Okay.
what happens is you can place within this also. Let's say your this is your you snapped it over here. Okay, but it should not your cells cannot even have this dimension. It should fix either within one box or complete two box or complete three box. But this is the minimum. See, what happens is the foundry is having their tools to manufacture it, right? This complete process of etching and everything. Their machinery has some resolutions, correct? So after the analysis, they are telling us, okay, see, I can just create, see, all the cells ultimately are nothing but formed of your layers itself, right? We look it as a gate, this will look like this. There is nothing inside. There will be polysilicons, implant layers, metal layers, correct? So they are stating, see, our resolution is this much. So please make, they're telling standard cell team, see, don't make any cell lesser than this much. Okay, this cell site row. Your basic cell also even of least drive strength has to be this much. You can go into multiple drive strength and increase it, but the multiplication factor is your minimum resolution, correct? So
Yeah.
all the standard cells is only allowed to sit in your core site. Rest which are being allowed are set into your IOs that are all related to, I said, right? Your
Okay.
ESD cells, your IO pad cells, your power ring structures. But since we are looking into standard cell library, it will all sit in your core site.
Okay, ma'am. So at the site area, we have core site and other name is
I
Mostly
think
for standard cells, I have looked at core site. I have not looked into it. What are the cells which are IO pads? I have to look at, I never opened left for IO pads because something done by upper management. Maybe for IO pads, if you look at it, there have to be a different site because it cannot sit in your core site, correct?
yeah, ma'am. Yeah.
I
Ma'am.
have not even worked with ESD related stuff. ESD is where is it allowed? We have to check it. But yeah, definitely it's not going to be core site.
Okay,
All
ma'am.
only the standard cells are allowed to sit in the core site, whether it's P or that's what you called combination or sequential.
Yes, ma'am.
Okay.
Ma'am, could you once brief about this class core, ma'am?
Okay. So class core is nothing. This I said, right? One is I mentioned about the die area, correct? One, the complete, your complete block is called as your die, but your
Yes, ma'am.
internal main core logic is not allowed to sit anywhere. This is called as core. See, every industry will have a calculation. See, we are not too much deep diving into it that how they land up into the calculation because they have worked with all this foundry and came up, okay, we are giving this much space, we are having this much port dimension, so we will maintain this much. So when they are giving, right, it comes up through, see, if I'm not even sure that how many of you have work experience, this floor plan, there is a full chip timing, full chip layout team. Okay, they only decides the blocks of this area. Okay, they at the from their end itself they will give us the command stating, okay, they'll provide a def stating, okay, this is the B box of my core area, this is the B box of my die area. Ultimately tool will understand there is core to die spacing. So what it is trying to say that whatever cell I have mentioned, it is only allowed to sit in the core logic. Okay, this area which is there, it's normally for IO region. Okay, there can be IO ports, there can be IO pads, correct? You are not allowed to make your cell sit at this. Okay,
But the
Okay, see,
site here, the core site also says the same point, no, ma'am.
the core site is specifically stating that within the site row, core site, see, this is a core site, okay? See, core can be anything. Okay, when you're looking at, for example, if you look at macros, right? Macros never, you're allowed that your macros cannot follow this core cell site. You're allowed to make it sit anywhere. Okay, but the standard cells has to be placed in specific core site. Okay, macros, the hard IPs or soft IPs which you develop are, for example, from the memory team they have developed, right? This is not necessarily that you have to snap it to the grid. They have a different rules from there. And for example, if you're taking up the memory from Micron or from Samsung, okay, so they are not specifically telling that it has to follow your core site rule. Okay,
Okay, ma'am.
this is a bigger class stating, okay, within the core logic, within the IO logic, this site is stating, okay, within this specific only I have to sit.
Okay.
Have you performed any time, you have used the tools?
Oh, yes, ma'am.
Have you ran any command called as check legality?
Yeah, it says about whether some flops are getting overlapped or not.
Huh. Cell on site, cell not on site. There are
Yes,
8,
ma'am.
10 rules, VT
No.
with, okay. How
Yes, ma'am.
does it get to know? It is trying to say that, okay, I was expected to sit in the core site, but I am not sitting on the core site. This is the way it checks, right? So there, then the check legality fails. So from here we get an understanding, okay, my standard cells have to sit within the specific B box, which is called as core site. Okay, this is just a bigger bucket sitting entire core, but then they have given it smaller, grain, they have fine-tuned it and sitting only within the core site.
Okay, ma'am.
Okay,
Okay, ma'am.
then we have something like same goes for your pin pin A, pin B, correct? So pin B is also there. It is also for signal. Then you have what port is used. If you ever guys look into it, just once if you have the access to the left, majority of your standard cells have their pins in max metal 1 to metal 2. Okay, very hardly they will have in metal 3, but metal 1 and the metal 2 are all your standard cells input pins. Okay, the same goes that, okay, we even have something for your this pin Y. Now pin Y will have just a different direction. Okay, the direction has to be the output. Okay, now if you look at here, that there is a possibility. Okay, I have definitely taken this example. If you look, there are two different rectangles which are being mentioned, correct, instead of one rectangle. Maybe, see, we don't know how the standard cell team does this formation of this. It can happen that they have taken up two different metal rectangular metals which are overlapping with each other. Okay, it could have happened, for example, this is one of the metal they have used, and along with this, let's say they have created it with something related to this metal as well. Okay, or we don't know the way, but it is possible that sometimes they can have a complex structures. This is mostly seen at one, even I have looked at one or two at even at the output pins. I am not very sure about the deep analogy that why do they are doing this, is it related to something, but they can have a complex shapes. So it shows that there are two rectangular shapes that are being used. Okay, so this is the overall information which is present about your, this is which file, guys?
Is left file, ma'am.
Left side.
Left file, but I bifurcated into two left files, right? This is which left file?
Standard cell
Standard
physical
cell.
library.
Standard cell physical library, correct?
Ma'am,
Now,
could you please explain the size 0.5 by 2.7?
I have said 0.95 is your width. Okay, now this is,
Okay.
okay. See, in your timing library, you directly have an attribute which is called as area. Okay, but what happens is here they need to give you the proper bifurcation that what is my width and what is my height. So it is trying to say that I am 0.95 is my width and 2.47 is my height. I am this in X, I am this in Y. Okay, every cell that will come to you will come in the form of this rectangular boxes. Inside it can be anything related to AND or AI or your flops, everything. But they will give you it in the terms of boxes only. Okay, if you look at your, open up your, even in your FC GUI and everything, you will see it in the form of boxes. Okay, when you go in and right click and do the schematic view, you will see inside this box which cell is present. Okay.
Okay, ma'am.
See guys, if you see, whenever you are learning anything and you need to try to correlate it. For example, you have heard a statement stating that if your drive strength increases, how does it affect your timing? Can anyone just unmute yourself and just let me know, how does a drive strength help? How does a drive strength and a timing, your delay correlates?
Delay reduces, ma'am.
Delay reduces. Okay. Have you ever wondered what exactly drive strength, how you're saying, how will you increase your drive strength?
Drive strength, nothing but same. We have same standard cell series. We have 2 or 3 standard cells will be made together. It becomes one big cell.
How fast the input is delivered
No,
to the next stage?
See
like it
guys,
is, we are varying
very
the width
simple
of
to
the
understand.
channel length.
Now, see, understand it, very simple concept. This we have learned in our 10th standard. Okay, for example, if a resistance is in series, okay, let's say for example, two are there, two resistances there. This is called as R1, R2. What is your effective resistance?
R1 plus R2.
R1 plus R2. Okay. Now you know that the concept of parallel.
Yes,
Okay.
ma'am.
If there is R1 and R2, what is the effective resistance?
1 by
For
R1 plus 1 by R2. R1 R2 by R1
R1.
plus R2.
R by
Ah,
two.
anything. Okay, okay. Understood. R1, R2, R1 into R2 upon R1 plus R2. Correct? Now let's say it was of, let's say 1 kilo ohm, 1 kilo ohm. How much will be the effective resistance?
2.
And if this is there, then how much it will be the effective resistance?
Less than 2.
0.5.
0.5 kilo ohms. Okay. Where is the resistance decreasing?
Parallel.
Parallel. Now, resistance is the main contribution. I said that when just keep this mind in formula. Tau is equals to RC. R is the resistance which is being offered. This resistance only affects your transition. If your resistance is increasing, it will increase your delay.
Yes,
But
ma'am.
if your resistance will decrease, your delay will decrease,
Decrease.
correct? So now from this basic understanding, where is the resistance decreasing? Where is the resistance decreasing? Series or parallel? Parallel,
Parallel.
correct?
Yes.
So understand it. Similarly, what would have happened it, right? Inside your design, when they have increased your drive strength, they have done nothing. They have attached two cells in parallel manner.
Okay, okay.
Okay. So you understood in very simple logic, correct? There is no rocket science I'm saying. It's a very simple logic that two cells are attached in parallel. And since they are attached in parallel, your size will increase. So just don't believe my word. Open up a library, look at the same cell with same two, it has to be 2 cross 1. Okay, 2 input, 1 output AND gate. Just open it and look in your one file for drive 2, look one for your drive 3. Definitely you will see that your X would have increased. Why? Because they are connected in parallel. That's why whenever you look, right, your one drive strength may occupy one cell side row, but your two drive strength might require a two cell side row. Okay, so this is the way you need to correlate. Okay, so that's why this size is nothing but your width cross height. Okay, your
Hello.
hello.
Yeah. You I mean, you're saying that they're just put in parallel, right? So by that, do you mean that your inputs and outputs are shorted of the same cell?
The inputs are sorted.
Yeah. Okay.
The
Yeah,
same
okay. Got it.
inputs are, it won't come 2 cross 2 is connected to 2 cross 2. It won't become 4 cross 1.
Got it. Got it.
Okay,
So
the inputs are
indirectly, the
sorted.
inputs and as well as outputs, right? Your inputs
Yeah,
and
yeah, yeah.
outputs are shorted to
Correct.
make it in a parallel structure,
They
right?
have just attached one more PMOS and one more NMOS in the parallel mechanism.
Okay. Okay. Got it. Yeah.
Okay, so you guys understood completely about this one, correct? Oh, I have to erase it. Fine. So from this, you understood that the physical library contains information about the physical cells, like physical attributes of the cells, like your size, symmetry, where will it sit, core region, what are the direction of the pins, and what it is used for, whether it's used for signal or something related to it, right? Now, one more thing is, okay, this is, I have taken an example for your flop, just to make you explanation, okay? The same way it is sitting in your core area, foreign DFFX1. See, this is something which is used only for hierarchical design, not for your standard cell design. So it is always saying that I am also 0, 0, origin is 0, 0. You are allowed to flip me through this. I am sitting in the core side. This is my site, everything. Same remains. Okay. Just over here, if you look, if you look over here, the pin D is also signal. Okay. Clock is also referred as signal. Okay. Q is also signal. Just if you come over VDD, I just wanted to give, see, VDD, it will come as your power. Okay. Sometimes I think, guys. Okay. If you look at it, this direction has to be something. If you look, direction for power is called as in out. Okay. It's not power. The direction is referred to as in out. Okay. And over here also, VSS, VDD, everything is mentioned. You use, I said there are three different things, either signal, or there is a power, or there is a ground. Okay. Then it has all the related information. One more attribute which I have defined over here is something which is called as OBS. It stands for nothing but your obstruction. See, when the standard cell team is giving you a file, right, they would have internally we are not sure how they have made this design. They are saying that, okay, if you're using this cell, we have an obstruction. Obstruction is nothing but a simple routing blockage. Okay. That is saying that we are having an obstruction for metal 1, and this is the coordinate. So what happens is, right, for example, if there is a metal 1 over here in this direction, when you are trying to use this cell in your design, you are not allowed to attach any, for example, if this is the coordinate. Okay. If this is the design, for example, this is the cell where I'm using, and let's say that they have mentioned that, for example, within this area, there is an obstruction. Okay. So what has happened, for example, if you're doing any routing or something, don't try to make anything go on this area. Okay. Otherwise, what will happen? It will create a short stating this and this metals are being shorted, right? Because that is being not allowed. So what happens is, within their design, if they have created some routing blockage, it can be for their purpose. They have designed it. You have to give this information in this form of obstruction layer. That is saying metal 2 can go over here, metal 3, metal 4, but just metal 1 cannot go over here. Okay. So this is just a simple way for your obstruction stating your routing blockage which is present within your standard cell. Okay. Just give me a moment, guys. 1 minute. Okay. Sorry. Yeah. So guys, do you have any upcoming
Ma'am,
class?
only metal 1 layer. Ma'am, one more doubt.
Yeah. See, what happens is the standard cell teams is majority of the time, all your inputs or your design, I said, right, it is restricted to metal 1 or metal 2. They are not using any metal 3, 4 or something. You open up your design, you just look at, you just hover over, if you have your FC or anything, just you go and hover over your this pin, and you will get that it is built in either metal 1, metal 2. Very hardly for any of the hierarchical designs which are complex designs, it can go to M3. 99% of that time it is being restricted to metal 1 and metal 2.
Ma'am,
Guys, do you have any class at 7? I'm not sure. Different class at 7 p.m.
No, ma'am, no.
Let me know once it's up.
Yeah, it's showing me.
Okay. So that's not working. Fine, guys. So we have now studied something which is called as standard cell, or your macro related left, which is your physical left. Okay. So we looked into it. What are the contents? First is your cell name. Okay. What was the attribute used for the cell name? They have used some different attribute, right? What's that attribute to
Macro.
refer a cell name? Macro. Great. Always understand that when you are searching, see, sometimes it happens, right? When even I am doing it, I am trying to grab. See, when you go into the real world library, these files are of like lakhs of lines. If you try to open it up, it might take a lot of time. So what we have to do is we try to use this uh, grep commands, awk, sed, and everything. From the Unix also, what you can do is try to grep it, right? So when you are trying to grep it through your library, you have to use the keyword as cell. While through you are using it through left, which is your physical library, you can use the keyword as macro. Okay, so it has all the information related to all the cells which are there in your design. Okay, then we looked at something which is called as class. Okay, I mentioned whether it can be your within your core area or your IOPAD regions. Okay, then there was something which is called as your cell origin, correct? Which is always in terms of standard cells, what was the values? Guys, what was the value for cell origin?
0.
0, 0. This is being used to refer because we are going, because see, you have to use a reference to tell the tool, okay, from this 0, 0, this is where my ports are being defined, correct? From this area, I will have an abstraction. So you need a reference. So for this, they are telling, okay, all the cells you consider as origin 0, 0. And then from that origin, we have referred other attributes. Okay. Then something called a cell size, which is of your width cross what is your height. Okay. Then there is something which is cell symmetry. Okay. So what was cell symmetry?
Either we can flip on x-axis or y-axis.
Okay. So you're allowed to either flip on your x-axis and you're also allowed to flip on your y-axis. Okay.
Hello.
Hello. Hello.
Hello. Hi, ma'am. Yeah, if you want to take the 2-hour class, you can take it up to 8 also, right? Because there is one.
Yeah, I had a word with I'm not able to
You can
recall
2-hour.
the.
Take
Yes.
2-hour class, no problem, right?
Yeah. Somebody from
Up to
basics, I
8:15
think
you can
that
do.
ma'am joined, but she allowed me to take it till late.
No. Yeah. You can continue, right? You can take 2 hours.
Sure.
Right?
I'm continuing. Yeah.
Okay,
I'll continue. Okay. Fine. So we are what I was stating that you are allowed to flip your cell across x-axis and you're also allowed to flip your cell across y-axis. Okay. And the next thing was then your pin information stating what is your pin name, what is the direction, what was its use, what was it possible usage. It can be used either for your signal, your power will have something attribute called as power, and your ground or VSS pill will have something as ground. Okay, so we are clear with this. Now the second bucket of what you call it as your physical library comes into your picture, and what you call it as technology library. Okay, see, you guys have heard with different tech nodes called as, we have moved from 180 nanometer, and you would have heard about those who have an industry experience, right? They know something called as TSMC N3E, N3P, Intel 18A. Okay, have you guys heard about this terminology, Intel 18A?
Yes, ma'am.
You know what it is trying to state?
1.8 nanometer.
Channel length.
Yeah.
Channel length.
1.8 nanometer, 18A, because they are stating everything in terms of Armstrong. Okay, it is 18 Armstrong, which is nothing but 18 into 10 raised to minus 10, which is nothing but 1.8 nanometer. Okay, approximately similar to your TSMC 2 nanometer or your Samsung as well, right? So, hello?
Ma'am, sorry for disturbance. Ma'am, I am newly joined it. I do not know about the physical design basically.
Okay.
So, is there any classes for basic PD?
Yeah, there is a class. Guys, who takes your basics PD? I'm not sure.
Ma'am,
There was
register
someone who.
takes around 7 o'clock. They start the basic of PD.
Guys, I'm not sure what's the confusion over here. Who takes your basics PD class, guys?
Ma'am, actually, yeah.
Ma'am, I'm the one.
Who is the one? Just guys, can you just name
We'll
yourself?
take the basics.
Yes, ma'am. I'm the one, Indumati.
Okay, Indumati, you are the one who takes the basics of PD, correct?
Yes, ma'am.
So today, this class has been cancelled for basics, right? I'm continuing with the advanced.
Okay, ma'am. You will continue. I'll start on Monday.
Okay, okay. No issue. So the person who joined, right? The person, I'm not sure. Can you just name yourself?
Ma'am Bharat.
Okay, Bharat. So Bharat, today there was a class at 7 p.m. But because there is an advanced PD class which is ongoing, maybe like we'll have this class on from Monday onwards for basics of PD.
Okay, ma'am. They start from the Monday, yeah. They already have some classes previous.
Guys, can you? I'm not sure about guys. You have already started with basics of PD?
Yes, ma'am. I
Somebody.
started PD classes also. Already 2 classes also completed, ma'am.
Okay, so that is completed. Bharat, so what you can do is you can reach out to Rajat and ask for the recording sessions.
Okay, ma'am. Thank you.
Okay, no issues. Yeah. Fine, fine, fine. So guys, where were we?
Yeah, technology left. You're discussing about nanometer, which node 180A.
Okay. So yeah. So see, guys, understand there are few fabrication units. You need to understand what are the fabrication unit, right? Intel has its own foundry. It has its own fabrication installed unit. Samsung also has it. The famous, which is everyone has uses and it's the best across the industry standard, is you know is TSMC. There is something which is also called as global foundries, correct? So all of these, see, if you're going to understand it in a very layman language, for example, the every person states that, for example, there are 3 different hotels. Okay, all are preparing their dishes, correct? But understand that maybe there is one, let's say there is one 3-star restaurant, one there is a 5-star restaurant. The for example, the equipments they are using, for example, the chopping board they have, the grater they have, the oven they have is of very great specification. So these are the small equipments, right? I'm not sure if you have ever visited to a foundry or something. Okay, they have a very good quality of high resolution equipments. So they have, like, for if you're taking us 5 nanometer, you're taking us from 3 nanometer, 8 nanometer, 28 nanometer, anything. We have different machines being installed for this. This machine has specific requirements. Okay. So this requirements, they are stating that, see, if you want to order this recipe from us, we will use this kind of machine, this kind of a grater, this kind of a mixer, which does the fine grain within 1 second. Okay. So this is kind of a specification. They have to even pass it on to us. Okay. Now you understood that how the cell will look like. But you know that the interconnection of these cells, correct? A cell A has to talk to cell B. Okay. You cannot directly connect the pin of Y, output of Y of your AND gate directly to an input of an AND gate. Okay. It has to be routed through something which is called as wire. In our day-to-day life, when we look around it, okay, wire looks, cable wires is there, correct? But in your VLSI, this has been termed in different types of metal layers. Okay. Now, this metal layer information has to be passed on to us, correct? So they will give you, see, we are working on TSMC 3P. We have this kind of a metal stack. The word terminology used in the industry is called as metal stack. Okay. So they will say you 19 LM. They will say that this is a 19 layer metal stack, 17 layer metal stack. There is a very different convention also, 1x, 2x, B3. We are not going that detail. If I have get a time, I'll get you exactly what it is, all this layers definition, how do they define it. Okay. But we just refer it as a metal stack. Which metal stack are you using? Okay. So they will give us this guideline. Okay. We have 17 metal layer stack. We have 19 metal layer stack. We have 21 metal layer stack. See, the budget will increase, right? For example, if you're going to use 21 metal layer stack, what we will say, we will charge you that for each design, let's say a hypothetical value, 1 lakh rupees. Okay. And they'll state you, I have 11 layer metal stacks. You can use that as well. So they will say that we are charging it just it for 30,000 rupees. So it's a trade-off that the company wants to choose, right? See, the larger the number of layers will be there, right? This will help you to resolve your routing issues, congestion issues. Higher the metal layers, you will use all the highest metal layers for your routing, for your CTS building. You know the relation between the resistance and this metal stack, right, guys? Anyone of you know, right?
The metal layer increases the resistance decreases.
Yeah. So as your metal layer, when you go from metal 1 to metal 10, your resistance will keep on Decreasing or increasing?
Decreases.
Decreases, right?
Yes, ma'am.
And anyone of you are aware why does it decreases?
Because the metal
But
Layer is
Wood is more.
Yeah. So
will
width keep
increase
on
from metal 1
increasing.
to metal, metal 11 or metal 10, top metal layer. So yeah, width keep on increasing.
So guys, it's a very simple mathematics, right? Which you have already done in your, I'm saying that even in your, so you say that your resistance is inversely proportional to your width. Okay. So what happens is, as and when your width will keep on increasing, your resistance will keep on decreasing. Okay. So what happens is, this all metal layer information is provided in your nothing but your TechLef file. Okay, this is your technology library, and they call it a dot .techlef, or somewhere I have seen it even in the form of .tf. Okay, so now you have to understand from this file, from where do we get it? Okay, so any guys, any information like who will provide us this file?
Foundry.
Foundry, correct? This is not something that you can get from standard cell library vendor. Okay, this is the file that you'll specifically and only get from Foundry, because the Foundry is going to fabricate your design. They know the rules. So they are going to, this is a kind of a manual they are going to provide to you. Okay, so this file is also in the format of ASCII. Okay, any file which is in the form of, if you open up and you are able to read it, mostly it's in the form of ASCII. Okay, if you're not able to read it, it's in the form of very different language. It's almost a kind of binary file. Okay. So TechLab file just.
Ma'am, what do you mean by SK?
SKI format. Not sure what complete it stands for.
ASCII format, right?
Yeah, ASCII. AS. Oh, by
American Standard in.
Sorry, asking.
Yeah,
Okay.
ASCII. This one. ASCII format. It's a standard format which is used across all the industries. Okay. Just I said that your library, your timing library will be in the form of what I told, Liberty. Okay. Your this file is Liberty is a what you called it is a format. This is your, I'm not sure what does ASCII stands for, guys. It's some standard.
Communication interchange.
Pardon?
Application specific integration circuit.
Huh?
Application specific. That is ASIC, FSIC and FPGA design, correct?
American
it is the
Standard
American Standard Code for
for
Information Interchange.
Code interchange, correct. So it's a format. Okay. It's a human readable format, guys. Just understand, whenever I'm saying it's an ASCII format, it's a human readable format. Okay. The way you look at it, design, right? It's nothing but it's kind of an attribute and a value, key value pair, right? I am always saying class, core, symmetry, XY. Okay. This is just the way it is being described, correct? So it's kind of it is, the analogy is a bit similar to a key and value pair. Okay. Key is nothing but your attribute and what this attribute is trying to define it to you. Okay. Now, within this, let's see. So this file is being provided in the form of, this is provided from the Foundry. It's in the ASCII format. It will just have the rules about your layers and VRs, because that's are necessary for the process, technology process to happen, correct? Now, if you look into this file, okay. Acha. Before this file, understand, you guys are aware about, this is the main intention. You need to be very thorough with the terminologies, okay? What does, let's see, this is trying to see it. Okay, see guys, have you heard about, all of you aware that all the communications between the cells happen through something which is called as metal layers? Okay, now in order to use this metal layers are laid down on something which is called as track. Understand the word track, okay? You cannot place this metal layer anywhere. Okay, so this dotted line, okay, which I have tried to depict, correct? This dotted line which you see is nothing but you call it as track. See, everything has to be placed upon something, right? The cell was allowed to place on your core site, okay? Core site, or you call it as cell site. Your tracks are allowed to be placed only on your metal tracks, okay? If once maybe next week I'll try to take your sessions through this tools, right? We have the access. Guys, can any one of you just help me to guide through setting up the tools? Because in industry, we just have the access to the commands to open it. I need to set it up. I'm not set it up yet. Any one of you who's available during the weekdays, and I'll be all, my meetings would be done around 8 p.m. Anyone who's available after 8? Have you ever, you guys have started using the tools, right?
Ma'am, please contact me.
Who? Can you just name it?
Indumati, ma'am.
Okay, Indu. I'll take your contact from Rajat and I'll take the help from you.
Okay, ma'am. Okay. Sure.
Yeah, sure. Thank you so much. Okay. So guys, there is something which is called as track. Okay. So your metal layers has to be placed on these tracks only. Okay. You cannot place it anywhere around the track. Okay. Now this is your metal one. I'm saying this is a metal one. Okay. Now this is your, whatever is your width of the metal is referred as something which is called as width. Okay. Now, when you refer to the word spacing, okay, it refers to the distance between the edge of two metal itself. Okay, you can look that this is the spacing between the distance from the one metal layer to the other metal layer is called as spacing. Okay, and the distance between the two tracks is called as your pitch. Okay, just be familiar. These are three different terminologies and you have to have a good command on it. Okay, that what is your pitch, what is your spacing, and what is your width. Okay, now you know that in the industries, all the layers are there, have a particular direction, right? See, we can't make all, see, if you use all the cells in the horizontal direction, it will lead to congestions. And it will then, your design has to be too much greater in your width, right? So what the industry came up with, let's have it in the form of horizontal, vertical, horizontal, vertical. So what has happened, right? One of the metal layers, see, guys, you have to understand it in the 3D perspective. I'm not able to draw it over here in the 3D perspective, but understand all metal one layer will be on one floor. Consider it as a form of a building. Okay, analyze it. Just that all your, whoever is on your first floor, right, is your metal one. Whoever is on your floor two is nothing but your metal two. Only things all are on top of each other, but the way they will go is they will go orthogonal. You understand the terminology orthogonal is? See, one will go in this direction, okay, horizontal,
One
and
is in
one will
horizontal and one is vertical.
vertical, and they will be perpendicular to each other. Okay, and over here there is something which you called as contact via, correct? Via is also nothing, it's also kind of a metal, but in order to connect with, to have maintain the connectivity between two metals, right, there is something which is called as via. Similarly, for example, there is someone who is staying on floor 1, wants to communicate something, someone who is staying on floor 2. How will they communicate it? They will use the staircases, or if you're living in a skyscraper, you can go through your lift, correct? So the same way, for example, a bottom layer has to communicate to your top layer. Okay, see guys, understand it. When your pin, I just stated your pin is there in which layer. For example, let's say now say VDD layer. VDD pin is there in, let's say, metal 1. Okay, now when your this power ports are there, this power ports may be something, let us say that it's my 11 metal stack layer, and I am using top 4 metal layers for my power routing. Okay, let's say M11, M10, M9, M8. Okay, so the power is entering into my design in the top layer. So it has to come down from metal 10, metal 11 to metal 10, metal 10 to metal 9, 8, and it has to come down till metal 1 and connect to the VDD. So what happens is all these connections between your layer is formed. This interconnection is nothing but something which is called as your via. Okay. So you just understood that the width is nothing but whatever is your metal length width is called as purely width. The distance between the edge of two metal is called as spacing. The distance between two tracks on which the metal layers are being laid is called as pitch. Okay. Now this information is needed to understand your okay, to understand your, what you called, this technology left file. Okay, now you need to understand, for example, there is something which is at the header section. Okay, there is something which is called as version. Similarly, see guys, I am seeing that every industry is generating some through their compiler or something, they'll have their version. In timing library, we look something which is called as revision. Okay, every time the revision might change. So there is something they are just mentioning, you just need to know what are there in the header section. Nothing of our use. We are never going, I in my life never don't go and use this. I just look at when you're initially set up, when you're starting at the setup of your project, just to have a notion, I just look at the metal stack, how many metal layers are there, and my first metal starts either from horizontal or from vertical. That's it. But you just need to understand that what is there in your header section. Okay, so it just states a simple version. Okay, then there is something which is called as metal case sensitive. See, understand that in this design they are trying to state that your capital M1 and small m1 are also different. Case sensitive, you understand, right? That you understand case sensitive, guys?
Yes, ma'am.
Capital M1 and small m1 are two different things for them. Okay, and if it is case insensitive, so even if you capital M1 is equivalent to small m1, so they are stating yes, the file inside this has different, even if there is m1 and if there is small m1, they are two different metals. Okay, so this is a standard they are following. So they are saying, oh, okay, I'm open. Then there is something which is called as bus bit characters. Bus bit character is nothing that you understand, right? For example, if there is a 4x1, let's say 32-bit ALU. Okay, so you always explain this in the form of this bus bit character, right? This rectangular. Even when you write a Verilog, you state it, right? If you mention it as 3 down to 0, it is a 4-bit bus bit width, right? You say it is in the form of bus. It's not a single. So this is trying to say, okay, I am also, if there is any characters which is in the form of bus, I will be in this square bracket. The next is divide by character, divider character, stating, okay, this is something which is used, for example, A1, then slash is kind of a hierarchy, stating this is inside this, I am this. If you would have looked when you're taking this I'm lecture, right? I can say that if you would have looked into a hierarchical cell, it comes after this slashes, stating within this hierarchy, within this level 2 hierarchy, this is the cell. It is trying to give you a divide by character, nothing else, no great use of it. Okay. This is just the header section. Then comes something as property definition. Property definition, it is trying to state layer contact resistance real. Okay, what happens? I initially also I stated, right? Sometimes when you're in the early state of analysis, the people are doing it, they may not provide you their calculation has been going on. See, they have to do a lot of simulations to come up to this value. Now they are saying that whatever, every layer will have a resistance, guys. Okay, understand that your wires are nothing but your metals will have a resistance, right? Because it will have some width, it will have some area. Resistance is directly proportional to rho L by A. You have you know this formula, right? So every layer resistance has to be also provided to us, correct? So they are saying that, okay, the layer will have some resistance which we have calculated and it's in the form of real. It's always real. Very early beginnings, if we are asking them, just give us a dummy value which is closer, they will give it. But every time when we are close to our closing phase, it's always we take up the real file. Okay. Then there is something which is called as units. Okay. Real means they have calculated and these values are real. For example, if you look at this 10.5, 5.69, if you look over here, right? See this property, if you look at the right side, if you look at, correct?
Yes, ma'am.
Okay, so this is saying, okay, 10.5, I am the real value for this contact metal. I am real value for this metal. Okay, metal 1. For this VR, I am having a real value of 5.69. This is not something dummy. Okay, sometimes at the initial phase, I stated, right? When they don't have the real value and they're still trying to figure it out, they will give you some dummy or a fake value. So that file will have it. That's very initial projects when it is being used. Whenever you get, when your project in the very stable state, you'll have this contact resistance all proper value. Okay.
Okay.
Then there is something which is called as units. Okay. Fine. To explain units, see, understand it. When you're talking in terms of, see, this design, when we look at it, even it when it opens up in front of our screen, our B box, our partition or your block, it appears in a very big format. Understand the reality that it is in millimeter square, nanometer square. Okay. Very small micron units are there. But this small micron units, we cannot refer it. Okay. There has to be some, see, the real world is dealing in microns, but in order for the tool to understand and have a good precision, right? It is converting it in the form of internal database unit. Okay, this is DBU, database units. That is why it is called as database micron. So it is stating nothing. Okay, it is saying if you are telling me 1 micron, I am taking 1 micron as 2000. That's it. If you guys would dump any def from your design, you will also have something as database micron 2000, 4000. Okay, all your values in your design, it will be in the terms of something which is a multiplication factor. Okay, let me say, for example, you just understand this 1 micron is equal to 2000 database units. Okay, now for example, I am stating that in my design, something is at location 400 cross 800. Okay, in your def, okay, when you will dump this def files, it will have the location of all your cells, your macros and everything, right? Where is your port and everything. So what, when you have to just go at the start of your def file, look at this keyword database. It will say you whether it's 2000, 4000. Okay, now whatever units are there mentioned in your design, right? For example, I stated, let's say your port is at some location 400 cross 800. Okay, so now what you have to do is you have to divide your 400 by 2000. Okay, because you need to get it in terms of microns. Okay, now we are doing a reverse calculation. 1 micron is equals to 2000. Now 400 microns is 400 dB. dBu is how much micron? So what you will do is you will divide 400 by 2000. It's nothing but 0.2, correct? Then your port location was 400 cross 800. 800 divided by 2000 is 0.4, correct? So nothing. See what happens is it's a there is an internal way that, for example, when tool is trying to work with this floating point, right? 0.2, 1, 3, 4. This is very small floating point. So there can result in some kind of inaccuracy. So what these foundries have stated that we will convert everything in form of DBU. So they are stating we will have a conversion factor DBU of 2000. Understood? Very simple. You just assume 1 micron is equals to 2000 dBu. Okay. Now there will be something at the below. There will be some section which is called as units. Same that we were seeing in our library, right? Time is being represented in my nanoseconds, capacitance in PF, picofarads, resistance, whatever is there will be in ohms, power. All your PVT related units will be mentioned over here. Okay. Now, the major section of this file was intended for all your layers and your vias and your contacts. Okay. So first is like they are saying there is one layer which is called as poly layer. Okay. Now inside this poly layer, it is trying to state that. Just give me one moment. Okay. Hello. Yeah, right. So the first, it is trying to say something as layer as poly. Poly is nothing but your polysilicon layer. Okay. So it is saying, okay, I am a polysilicon layer which is not used for routing. Okay. So it is trying, okay, this is the layer which is there for my polysilicon, and there is some which is master. See, all your implant layers and all this polysilicon layer have a type which is master slice. Even I'm not very sure, I'm not deep dived into it because I'm not using this information for designs. The majority of the information is used from your metal stacks. Okay, so all your poly and implant layers will have something related to type as master slice. Then there comes something which is layer as contact. Okay, there is a minute difference between contact and via, but they are just to connect between your different metal layers. Okay, just understand contact is also similar to via. Similar, not exactly, but there are contacts in your design. And this is showing that I am in the type of cut. Okay, if you look, see, via, when we are stating there are different types of via. There is, if I have to take a lecture, there is array via, stacked via. There are different types of via. 4 cross 1 via. Okay, just if I have to explain you, for example, there is, see, 3D dimension drawing is very difficult. Okay, guys, understand, for example, there is a horizontal layer, there is a vertical layer, and connectivity can only be formed in this layer. Okay, look it from the 3D perspective. Okay, What I can do is I can connect this bottom layer to the top layer through a single via. Okay. So this is just a normal single via. Okay. There is different which is called as 4x1 cut via. So what will it happen, right? Instead of connecting it through one different metal, it will say it is in the form of the squarish shape. Let us assume 2x2. Okay. Guys, understand it. It's very difficult for me to explain you in the 3D dimension, but it is a 2x2 matrix. Okay. Where these are the 4 shorter vias. This will have a bigger area. These are the 4 different shorter areas. Okay. So when you're reducing this, you have, this is called as 4x1 cut via. There can be 2x1 cut via. Okay. So this is, they're saying that we are kind of cut via. Okay. Then it will say something as spacing. Understood? What's the spacing means? And what the spacing I told you in the earlier example is the distance between the edges of either metal, or in now it is in terms of contact. So you there is stating that you have to maintain a spacing rule of 0.75. As you heard the terminologies DRVs, you call it, you may even call it as DRCs, but a very specific terminology is called as DRV. Have you ever heard about it?
Yes, ma'am.
Yeah.
What does it stand? At least what does it stand for?
Design rule
Design
violation.
regulations.
Design rule violations. Okay. See, even if in your designs you are meeting your timing, you're good with your area, you're good with your power. If your design is violating with respect to the main design constraints, right? And these design constraints are nothing but your min width, minimum spacing. If you look at it, right, there are a lot of things. Okay. So that is why it is saying, see, if you're placing a via closer to the another via, please kindly maintain a spacing of 0.075 microns. Okay. Otherwise, what will happen is, right? See, I'm saying that Foundry has its tools. It has a kind of a resolution. There will be some machine which is doing this, drawing this contact layer, this via layers. So what happens is, right?
Ma'am, spacing between 4x1 to 4x1 or within the 4x1?
No. This is between two different 4x1. Okay. If there is a via over here and a via over here, the diagram which I initially stated, right? You looked at the spacing between metals, correct? Metal 1 and metal 1, there was a spacing.
Yes,
Spacing is nothing but the distance from the edge to edge, correct? So it is trying to say that two vias, let's say between two 4x1 via, same via. Okay, you have to maintain that this is the via. For example, this is the contact. Okay, contact and via are nothing. They'll all belong to the type as cut. Okay. This is trying to say that if one via is sitting closer to the other via, please maintain a spacing of 0.075 micron. Yes, this is very vast topic. If I have to explain you in terms of how does a foundry manufactures each is it, right? You know that, for example, when you are building even a metal layer, when we draw it, you draw it very rectangular shape. When this process is being done, right, they have to do an etching. It is not necessarily, for example, when you are passing it, what happens? For example, you would have looked into it like they are designing it in this form. Okay, when they are etching it, it can happen. For example, this may be etched and it can become a thinner layer. Okay, so when you're closing two vias very near to each other and it is trying to, via contact layers are nothing but your metal layers. Okay, so what it is trying to do, for example, it does this, and now your next via is very close to it, and when it is trying to place it, it might happen that while doing this, it has placed it near to it because the resolution of that machine is not that great. So they have calculated it. See, our machine can only attempt to create these layers if they are 0.075 micron apart. So even if our tool does the mistake, it cannot bring both of them shorted. So otherwise, what will happen? This two via will get shorts, right? So that is why this foundry gives us this spacing rule. Okay, so it is trying to state the distance between the two has to be maintained of 0.075. Then it will say, okay, since it is a metal layer also, it is giving you a property saying, okay, I have a resistance of 10.5 ohms. Okay, they are not maintaining. See, that is why they have given you the units over here, that every time we are not going to mention this. Okay, now this is done for contact. Similarly, it will happen for, I have just pasted metal 1. if your is a metal 12-layer metal stack, it will have the information for all your metals. I have just put down very few important parameters that are being needed. Otherwise, it will have lot of attributes. Okay. So now, if you look into it, now you will come that this is the metal which is being used for routing. Okay. Direction, you have to understand this, that this is always going to be in your horizontal direction. Now you understand there is a pitch. The pitch is that the two different metal tracks for metal 1 has to be separated by 0.19 microns. So that is why I understand spacing, pitch, and width. So that was the earlier diagram I stated. Okay, so the tracks at which this has to be separated, it has to be 0.19. The width of this metal layer is 0.065. The spacing that you're allowed to maintain between two different metal layers is nothing but 0.065 microns. And this is the kind of resistance I have it. Okay, same goes, nothing but the other thing that they have explained is just for the via. Then there is no, see there, when you have, for example, metal 1, metal 2, there will be between metal to metal 1, 2, you call it as via 1, 2. Okay. Then between metal 2 to 3, you will have something which is called as via 2, 3. Correct? When you have something which is called as, so between each of the metal layers, there will be vias. And there is not necessarily, there will be one specific via, I'm stating, right? There can be different kind of via, 2 cross 1 cut via, 4 cross 1 cut via, there can be an arrayed via, there can be a stacked via. So all this information will be present over here. Okay. So this is all about your, for example, the primary attribute that has been, which has always been referred by an engineers is through these files. Okay. We don't go in depth because if I have to explain you, there are around more than 70, 80 different attributes. But for example, the terminologies which are being used for DRV is minimum width, minimum spacing. Correct? So all this layers information, how much layer stack is there. So for example, if I am telling you, you are not sure which metal stack you are using, how will you guys tell to know that? You will just have to go into your TechLab file, grab the word layer. Okay. Grab the word layer MAT. Okay. All the metal layer will be in this format. Okay. Otherwise it will try to come with contact and via. So you will just get, okay, it is an 11 metal stack layers. Understand which one is the first metal. Its routing is in horizontal direction. The later would be always in horizontal, vertical, this pattern. Okay. Now this file will also be of use when you are calculating your net delay. Why? Can anyone just tell me why will this file be of great use when you're calculating something related to net delay?
For timing.
For timing. How are you stating for timing?
Because delay is depending on resistance and capacitance.
Correct. Because the resistance value is being provided over here, right? You need to understand that this resistance value will help you to calculate your delay. Understood? Tau is equals to RC, right? See, capacitance value will come when there, see, what's the formula for capacitance? C is equals to epsilon A by D, correct? It will come when there are two metal plates on top of each other or parallel to each other. Then there will be a capacitance being generated. But this file will be used to calculate. There is one more file. With the help of this file, it gets dumped, which you call it as SPEF, standard parasitic extraction format. The SPEF has complete RC. It calculates it from here itself. It also has to calculate, for example, if you have routed in how much length, right? See, I have not given over here any specification with respect to length, correct? I have just mentioned that the width of this metal layer will be this much. I have not stated how much length you can route it, right? You can route it for 1 micron, you can route it for 5 micron, but the tool will have, okay, for this 1 micron, I have at least the resistance of this. So it will do a calculation and will find out, okay, for 5 micron, the resistance would be approximately this. And it will dump a spec file, which is called as RC spec file. So it will have all your net delays. So net delays are being calculated through the spec. Okay. And your cell delays are being calculated through which file?
Lib file. Lib.
Yeah, timing lib file. Be specific, okay? Don't say every time lib. Say through your timing lib or logical lib file. Correct?
Timing lib.
Timing lib.
Here 10.5 is for 1 micron of length, ma'am.
Yeah, they are using it as a 1 micron.
Okay.
For this.
The units are microns or the dB units, ma'am?
No. Even all your length perspective, I have not mentioned over here are the complete units, but these are all in microns. See, all your this information, this is in 10.5 ohms. See, this is trying to say resistance value, correct?
Yes, ma'am.
So the resistance units will be in the forms of ohms, correct?
Ohms. And one more, DRCs can also be called as DRVs, ma'am.
So that's the thing. There are a lot of design rule constraint, but we specifically when we call all this minimum width rule, minimum spacing rule, whatever checks you're performing with respect to the foundry specification, a very specific term is DRV. Okay, because if they are not being met, you will say your design rules are violated. Okay, that's why I'm saying even if you would have heard somebody, see, people will ask you in the interview. For example, if there is a design, I am very confident timing is been met. There is no setup and hold violations, and area is also met. But DRV is gone. Okay, now see, when you're doing the static timing analysis and everything, tool is not taking into consideration how your metal shape is there, right? It has to just calculate the delay, what it will do. I am this much length, this much width. Okay, I have this much calculation. Okay, net will contribute me, let's say 1 picosecond of delay. See, STA timing tool is not doing anything. It is not checking how your metal shape will be formed, correct?
Yes,
And it
ma'am.
will give you the results. Okay, I am met. But at the end, your design will go to your foundry, correct? And you're not meeting the foundry rules. So there is a possibility that when the chip is fabricated, right, your spacing rule is violated. So what happens when, see, all is the, understand that GDS, which I stated, right, it is nothing but all your metal layer informations. Okay, so it has nothing. For example, there was one, let me say this was one via, this was second via. Okay, this is via for our explanation. I have drawn it small. What happens is, for example, when the tool, the foundry tool is fabricating it, it will create a metal layer. Okay, it can happen. See, understand that tool which is also doing this fabrication can make mistakes, blunders. They are also taking their marginal error into their accounts, right? Okay, so now what they are doing it, correct? They are stating, see, I have designed this via, and now what happened is, for example, let's say by marginally even your VR2 while fabricating it, it got touched. Now understand this via and this via were for different purposes. This was carrying some data signal. This was carrying some clock signal. And what you have done, you have made them shorted, right?
Yes, ma'am.
So what's the use? Even if you did all your static timing analysis, your power was great. Anyways, you violated the foundry rules, correct? Now
Yes,
the
ma'am.
foundry will come. See, foundry, when they are doing this verification, they will definitely ask you, guys, just give us your DRV reports. Have you met it? If not, why will they even fabricate your design? They will say, see, I am telling you, see, this one manufacturing costs lakhs and lakhs of rupees, right? Before
Yes,
even
ma'am.
starting, they will first prepare a dummy chip. The bulk production never starts. Okay.
Okay.
They will post silicon also, there is some validation. There are different roles. So just we always look at a very shorter picture. There is a post silicon validation. There also a lot of bugs comes into the picture. Then your ECO cycle begins. Okay, but the DRV takes the highest priority. Always understand your STA, your whether your area targets are met, power targets are met. These all take the secondary preference. If in your design you are having DRVs, okay, you have to first rectify those.
Okay, ma'am.
Okay, that's why they are called as design rule violators.
Okay. So can we say that DRCs are with respect to the STA, ma'am?
Now, those which you are calling with respect to ST and something timing view, we call it as DRCs.
Okay, ma'am.
Okay.
Okay.
Hello,
Yes.
anyone else?
It is opposite, right?
No, I think DRVs is the one which called as with respect to your foundry fabrication units.
Because in DRV we see the max cap, max trans, right? So those are related to the timing, but for the foundry and structural violations, those are design rule, what you call DRCs, right?
I will once again check it, but I have referred DRVs as the one which are called as design rule violators. And
Okay.
DRCs are with respect to your constraints, for example, timing or your power or your area. I'll once cross check it.
Sure. Yeah.
Anyone else was speaking something?
Ma'am,
Ma'am, this
DRV
resistance is
One by one.
Yeah, ma'am, we mentioned that resistance in this file. That resistance is for unit any specific area or for unit length or anything
It's
else?
for unit length cross unit width.
Okay.
Unit you understand. Unit means one, right?
Yeah.
When you say one, it's for unit. When the tool will do, see how much length you will route it, there is a way that see, if you understood that the delay was also been intrapolated or extrapolated. So similar way that the resistance for your complete depends upon your length, right? Because your resistance even is directly proportional to rho L by A. It needs to even look at what's your length, right? So depending upon how much, see, Foundry doesn't know how much length you will route, correct? You can take it to 2 microns, you can take it to 3 microns. They are not sure. They are saying, so 1 cross 1, for this one unit dimension, this is my resistance. Any other participant was asking some question? A girl was there over. Hello?
Ma'am, sign up stage we are checking ma'am. In sign up stage we are checking DRVs or DRCs.
See, when you call it as a terminology, a sign off, right? See, sign off means you have to perform even your LEC, you have to perform your VCLP, you have to perform your STA, you have to close your DRV, you have to close your DRCs. When you say the word sign off, what you're saying that you have done all the analysis, all the parameters in met with respect to the constraints point of view. So you will have to do all the analysis. There is nothing that you will do only DRCs and you will leave your DRVs. You will not perform, for example, you are meeting DRC's DRV, you did not perform a functional verification through formality or through LEC. Then how will you say that you have signed off? When you terminology as sign off, understand there are a lot of sign off checks. You cannot say DRC and DRVs are just a sign off. Your STA has to be met, your LEC has to be done, the formality using LEC. Nowadays, I'm stating, right, there is no designs which is not low power. All your designs are low power. Okay, so they will have all your checks related to low power, whether the intended isolation strategy is correct or not, the level shifter, wherever it is intended, it is sitting in their parent domain or not. So there is a VCLP tool, right, which does this all low power checks. Okay. So along with that, you have to look, you're meeting all your Foundry minimum width, minimum spacing related rules.
Timing DRVs is nothing but DRCs or different.
Timing, see, understand, whatever timing DRCs is nothing but your design rules or constraints are violated. Okay. Now see, basic understand, there is only majority when you bucket it up, there is two terminology which you called and you are very much aware. One is you call it as setup, one you called it as hold. Okay, this is the only thing which you are saying na, in your timing reports. The famous word is slack. Okay, setup slack, hold slack. Correct? If you do it with respect to deep in, you call it as setup and hold. Yesterday I said, right? Then you have to do something with related to asynchronous pins, which you call it as recovery and removal check. Okay. Along with this, there are also different checks which is called as min pulse width check. Okay. Min width check. Okay, so there is not, we majorly do these two checks. These reports also get dumps. Majority of the time it is being met. So that is why we are not looking into this report. But timing perspective wise, you have to look at closing your STA with respect to setup and hold. Setup and hold with respect to your deep in, and setup and hold with respect to your asynchronous space is nothing but your asynchronous and removal checks. Okay, along with this, you will look at clock gating checks. See, clock gating itself is a very vast topic when you are doing this. There is CGC related checks. Okay.
Okay, ma'am.
Yeah.
Ma'am, one more. Could you explain the manufacturing grid? Hello.
Yeah. Hello. Just give me a moment, guys. Hello. Just 1 minute. One. Hello. Hello.
Could you explain the manufacturing grid, ma'am?
Grid?
Hello.
Which grid?
In this slide.
Can you be a bit louder?
It's under the units, ma'am. Manufacturing grid, left side. Sorry, it's above the units. Database microns.
Acha.
Yeah.
Okay, manufacturing grid. Okay. See, manufacturing grid is nothing which I stated, right? See, every this foundry when it is developing your this, I said, right, they will have the lowest possible resolution. Okay. See, when you would have studied just with understand it with terms with respect to that there is a machine which is going to design this. Okay, so they are saying that the smallest possible unit for our tool to design is 0.025 microns. Okay, so this is a minimum resolution. Just understand this is a kind of a minimum resolution to which all your geometries, whether it's your cell, whether it's your layers, whether it's your VR, it should follow this grid. So this, just understand this is a unit which is being provided by your uh, that machine has some resolution that beyond this it cannot create any dimension which is lesser than this. This is the smallest possible minimum layer dimension that it can draw. See, understand, for example, if you understand, for example, if this is a pen, right? The pen has a different kind of width, right? See, understand it from the perspective of a foundry. Foundry is having a machine. See, since you have not visited a foundry, you will not know. See, when you're drawing a metal layer, right? It is saying that the thinnest possible pen which I can use is of this much width. You're able to understand and correlate with that perspective?
Yes, ma'am.
Okay, so they are saying that something which is lesser than this, if you are designing a cell which is even having a layer which is being built even lesser than 0.0025 micron, I cannot draw it, man.
It's
This is
about
not
a width or the length, ma'am, you're talking about.
the width, length. See, anyways, you can increase it, correct?
Yeah, yes, ma'am.
No, that's not the thing. I'm saying, see, this is that's why I'm saying, even if you look at my screen, I'm trying to say that each of the pen which you are going to use, it is having a different width, right? A thickness.
Yes,
It is saying, see, minimum is this much thickness. Every machine has some restrictions, right? So they are stating, okay, I am the smallest possible resolution for me is this much. If you are giving me anything lesser than this, I cannot design it.
Okay.
See,
So this
you
comes
understand, for
under
example,
DRV,
if there
ma'am.
is a this comes with a DRV. Otherwise, if you see, anyways, they are giving us the width with this, right? See, I'm stating, for example, there is a width of 0.065 micron. There is no such hard constraint upon it that you cannot double the width. If you know, well, that is a complete CTS concept that you would have heard about the terminology NDR. Anybody have heard about this terminology as NDR?
Non-default rules.
Non-default rules. Why they are called non-default rules? Why? Because this is a default routing rule they have stated. You understand? This is, see, you understand, these are my default routing rules that you have to abide with it. But specifically because of we are having some requirement with respect to CTS, right? CTS is something that your timing criticality has to be maintained. What we are doing is we are doing, if you call it as 2W, 2S, double the width, double the spacing. Okay.
To mitigate
Why
crosstalk.
you are increasing it? You want, see, if you double the width, right? Understand it. Very basic. If you, I stated, right, resistance is inversely proportional to width. If you are doubling the width, what can happen? Your resistance will reduce. If you are increasing the spacing, understand that your capacitance is inversely proportional to area. Epsilon A by D. I'm not writing the complete formula. It's inversely proportional to area, right? The area between the two metal plates. If you are decreasing the area, if you're increasing your, if see epsilon A by D, correct? It has to not do with D is the distance between two plates, right?
Yes, ma'am.
Understand how is the capacitance? This is a very basic electronics, guys. The distance between two this metal plates create a capacitance. Okay. If you are doubling the spacing, right? You are increasing your D, but you are decreasing your capacitance. Correct? Guys, are you with me?
Yes, ma'am.
Hello?
Yes, ma'am. Yes,
So
ma'am.
see, understand, see, why are we doubling the width? Why are we doubling the spacing? It will eventually helps you to reduce the delay. Correct? See, there is a very restricted number of metal layers and the number of instances in your design are going to be 1 lakh. Within this, for example, if you have 10 10 metal stack layers, let us assume that the top 3 is being gone for your metal purpose, power routing purposes. Now you have to utilize the next, let's say 5 and 6 is available. Okay, so within this 5-6 metal layers, you have to do your routing for 10 million instances. So what they are doing is, okay, for example, we will use this metal layers, but we will alter this default routing rules. We will make them double the width, double the spacing. So that's why they are called as non-default routing rules. Okay, so there is not something that they are just telling, okay, if you are going to use the metal one, the minimum width that you have to maintain is 0.065. You increase the width, no issues. Minimum width that has to be maintained is 0.065. Length, so you can take it at your cost. See, you cannot increase the length as per your expectation, otherwise your tran will go bad. Understand it very big. See, our VLSI industry had a lot of trades off. It's not simple coding. Okay, I will run this code, I will get this result. If you're increasing the length at the, see, if you're this a single wire is going on through let's say it's routed to 120 micron. Understand that it will lose its signal integrity. The shape of the signal will degrade. It is traveling for a lot amount of time. That's why you keep on inserting the buffers if there are long necks, right? So you cannot even keep increasing your length as you wish. You have to understand that, oh, my tran will go bad, it will affect my setup. But there is a way that you can, okay, I'm limiting to this much microns. I am even meeting the timing and I'm good with it.
Okay, ma'am, each metal layer is having their own widths, no, ma'am. Then what about this manufacturing it?
Each layer is having their own width. See, this is not I'm spacing that only with respect to this one metal layer. There can be something. See, this is one particularly I have mentioned. There can be something which is even lesser than this, correct? So there can be different metals. Let's say I am saying these are taken up from different vendors. I have taken it up, right? To just explain you the short rules. The minimum metal width that it can have could have been 0.025.
Okay, but when we go from metal one, the width will get increased, I think.
Yeah, width will definitely get increased. I am trying to state that this unit, then this picture are two different. See, I cannot take a picture from entire this, and I cannot take the picture from my company and try to paste it over here, right? I am trying to grab the picture from the internet. Even I'm not typing it, correct? For example, this is a picture which is taken up from one different unit, if you understand, right? There, the metal, the base, the minimum first metal layer that was there, it was 0.025 width.
Okay, it's about base layer, I think.
The smallest possible layer, not I'm saying base layer. Don't, now you will get confused with whether it's polysilicon or implant layer. No, the smallest possible metal routing layer width that has been possible, or the resolution for the lowest metal layer is 0.0025.
Okay, ma'am. With poly and cut, other than this, do we have any base layers, ma'am?
Poly along with this, the cut is not even this poly layer. Okay, all your implant and polysilicon is in a different. It comes into the master slice. Okay, cut is definitely for your vias. If you look at the poly, right, it doesn't have a type as cut, correct?
Yes, ma'am.
So only contacts and your vias will have a type as cut. All your metals will have type as routing. Only I have seen poly. I'm not sure. I'll have a look with. I'll open up one of my TechLef and try to look at if there are. I have not looked into it, because see, this poly layers and this are not. This is an internal within your design, correct? I am not going deep down into it and looking into it. My intention is always with respect to the metal layers. Even when I am working there are rare chances that I open up the metal layer just for using it, correct? When I said, when you're initially setting up your project, I have a notion like how I want to understand how many metal layers are there. I just grab the layers metal. I'll check once. Or you want to know me like what are the different types of layers which are available for type master slice, correct?
And the different base layers we have.
Okay.
Okay.
Fine, guys. Then maybe like majority of the inputs has been covered. We will cover up the rest. For example, one of the main input that is there, it will take more than around 2 hours, for example, because that's an SDC file, right? Your main constraints file, correct? And constraints are not easy. Your constraint approximately will take more than 3 hours. Okay, so that will start from maybe if I'm free tomorrow, I'm not sure. I'll just let Rajat sir know if I'm taking the class tomorrow.
Okay, ma'am.
Ma'am, will you share the PPT?
No, I'm not sharing the PPTs, guys. I want you guys to actually remember it. Every
Okay,
time when I'm
okay.
coming up in the class, every time I see Ravichand, are you back?
Hello?
Yeah, Ravichand, where did you went at the start of the class?
Today?
Yeah, I took your name and you were not there, correct?
No, I answered about the when you said that American Standard Code.
Acha, okay, fine. So guys, I see if I give you the slides, you will refer it. I just want that next time when I'm coming, I want you guys to answer it. See, please prepare it. Come and just have a see. It will hardly take you 5 minutes to recall what was being done in the class, right? It's not for it's not beneficial for me. It's beneficial for you. I have already gone through it.
Yeah, okay, ma'am. Okay.
Okay. So guys, I'll tell you maybe maybe if I try to take at least 1 hour possible, I'll try to take up a class for at least starting with basic understanding of SDCs.
Okay, ma'am.
Okay,
Yes,
ma'am.
maybe tomorrow because Sunday.
Sunday.
So maybe from Monday, maybe 3 hours class long set might not be possible. So tomorrow is fine, ma'am.
Yeah, tomorrow, but I will let you know, so guys. Along with this, I have a lot of other tasks. It's not something that I'm doing only this task, correct?
Yes.
Okay. So I'll let Rajat sir know about it, and he will update you guys.
Okay.
Okay. Great, guys.
Okay. Thank you,
Fine.
ma'am.
Yeah. Thank you so much. Yeah.
Question, ma'am.
Hello.
Yeah, ma'am. One question, ma'am.
Uh-huh.
Ma'am, it's too early to ask for this. Actually, ma'am, I came across a role called PD CAD.
CAD
Yeah.
engineers are the one who designs the flow. Okay. You're not something you're going to work with respect to the blocks. Okay. Understand? CAD is a different role and PD engineer is a different role. You are the one who's going to design this flow for the PD.